Hello, friends. I am Davit Robakidze, and I was really glad that you liked the video series I offered you, so I decided to continue filming videos just as you asked. Today I want to talk to you about video routers, what they are used for, why they are necessary, and generally how video switching works. Because we use video switching not only in television stations or in complex broadcast facilities, but actually in our everyday lives as well. You might need this at any time, and it could always be interesting for you. So in this video, you'll learn more about video routers, how to switch video and audio signals, what the differences are between them, what equipment you need, and how and where to use it. Let's get started. A video router, or video switcher, is a device that provides better routing for video signals. We encounter video signals both in televisions and in everyday use. For example, when our TV is connected to a set-top box with an HDMI cable, both video and audio signals pass through it. Moreover, our computer is also connected to our monitor via HDMI, DVI, VGA, or another type of cable. Let's imagine we have 3 laptops and one monitor that has only one HDMI input. But we want to be able to select the signal from any of the laptops to display on our monitor. Or we have 3 set-top boxes, SilkNet, MACD, or any other, and again, just one monitor. In this case, we need a device. And in the first scenario, we need to connect all the laptop signals to the router, and then connect the router's output to the monitor. Now, let's imagine a more complex system. We have 3 computers and also 3 set-top boxes, and we want to be able to send any signal to any location. In this case, we need a router that has 6 inputs, and if we have 2 monitors, then 2 outputs. The number of input and output interfaces determines the size of the router. In our example, there were 6 sources and 2 monitors, but usually, in reality, it's the other way around. We usually have more destinations for the signal, meaning more monitors, than sources, like computers. For example, in our studio, we have 3 monitors, and we want to display several images on them simultaneously. In this case, we need a router with 1 input and 3 outputs. Typically, all modern routers can multiply the signal from a single input and send it to as many outputs as it has. For instance, if we have a router with 5 inputs and 5 outputs, and we connect only 1 cable to it, the router will be able to communicate from that single input to all 5 monitor outputs. Usually, a video router requires management. Imagine you have a 32 by 32 video router. You need some kind of interface where you can assign names to all the input and output interfaces. Similarly, you need to name the output ports just like the inputs. For example, if the first 10 inputs are connected to 10 video cameras, you can name them camera 1, camera 2, camera 3, and so on up to 10. And if the first 10 outputs are connected to 10 monitors, we can name them Monitor 1, Studio 1, Monitor Studio 1, and so on. Besides the fact that a video router should be managed by some type of software, whether that's through a web browser or a separate program, physical panels are also needed so we can quickly switch or route the video signal. It's essential to give the video panel limited access so that we don't accidentally change other audio signals. For example, if I have a monitor set up, which is connected to the router, it's necessary for my panel to be able to comment on and control all the signals from my router so that we can avoid human error. A video router typically carries both video and audio signals, but different routers handle audio differently. Modern, functional routers can take audio from any video input and assign it to any output. Let's imagine an example where I have 3 video signals connected to the first, second, and third inputs of the video router and a monitor connected to the first output. The third video signal has the audio of the first host, while the second and third video signals have no audio. I need to be able to select either the first or second video signal as the video source, but I always want the audio from the first video signal to be sent to the first output. In this case, we can choose any video signal, but the audio will always come from the first input even if we select the video from the second or third input. For example, from the start, I will always have the correct audio. Several video signals are coming into the video router. How can I tell which signal is good and which one is bad? For example, is the camera pointing in the right direction or is it out of focus? I can connect a monitor to check the video signal and see if all the cameras are working at the same time. But imagine we have 30 video sources. If I want to monitor all 30, I'd have to switch between video signals like crazy while checking them. That's why there's a feature called multi-viewer functionality. Usually, the multi-viewer is open on one of the physical outputs of the router, for example, on the first one. It can display either 31 or 16 signals at the same time. This allows us to monitor many signals at the same time and, among other things, to identify audio, so, for example, if the sound is lost, we can see it. An integrated multi-viewer is always very good. There are modular video routers. For example, if today we need a 28 input video router, my recommendation would be to buy a modular one, which physically, for now, will have a 28 input module, but will have the ability to expand, for example, up to 32, 36, or even 48 inputs. Also, just because we don't need certain router functionalities today, like a multi-viewer, embedder, or de-embedder, doesn't mean we won't need them a year or two from now. If the video router doesn't have those features from the start, it will be impossible to add them later. But if we choose a modular system, we can add those functionalities later by purchasing a license. The router, as the heart of the television station where all video signals converge, must be fully redundant. Typically, a video router is divided into two parts, the physical crosspoint and the software crosspoint. A crosspoint is a device that physically connects an incoming video signal to an outgoing one. Usually, a high-end router comes with two redundant crosspoints, so if one fails, the other automatically takes over. If we don't have a classic crosspoint, non-A. Many high-end routers also have duplicated video signals, and often they are not all of the same standard. For example, the first camera might operate in SDI mode, the second in HDMI, and the third in 4K. We need to choose a video router that supports all of our video signals. In this case, we need to consider not only the resolution, but also the frequency and the type of video signal carrier. In the previous video, we discussed whether there is HDMI and other strong types of video signal carriers, as well as various others. When it comes to IP type carriers, it's important to plan ahead when choosing a router and consider what types of carriers we're using. Accordingly, what types of interfaces do we need? The video router is essentially the heart of the television station. As I mentioned, it's where we need to connect all the video signals generated in the station. Feeding all video signals into the router provides significant technical flexibility. However, it's common that when we buy video products, we get a smaller one and switch some signals externally. Bypassing the video router in this way is acceptable in practice, but it's quite risky because if we ever need to take a fee from that source, it will become problematic later on. In addition, video routers have their own distinct advantages. Nowadays, modern video routers are already very different from classic video routers. For example, if our video router supports 3G, HDSDI, or 12G, that doesn't necessarily mean our router will be completely silent. For instance, if we want to work with IP for 21 hours, it's essential that our router supports this. However, in the case of IP technology, the router and the network switch often overlap with each other, which is why many manufacturers have moved towards modular routers. In this direction, which we've already discussed, just to make sure you understand correctly, what does this mean? A modular video router is a type of video router where you can install a card that provides, for example, SDI input-output, or it could be a separate audio input-output, whether that's Dante, AES67, Livewire, or something else. But you can also install IP modules if we're talking about IP. Previously, this was a completely separate topic for discussion. Here, it's essential to understand which path we're taking, because not every manufacturer uses the same approach. It's important for the video router to be reliable. For example, when it comes to video equipment manufacturers, like Evertz or Grass Valley, the video is handled one way, while some engineers prefer that for IP, video routers should be from brands like Cisco, Dell, HP, and so on. In this case, video routers are already crossing over into classic network video, like with switches, and not just routers. However, we still call them routers because, in the end, the video router is responsible for communication. It's very important, and sometimes even a very small video router, for example, one with just 100 or even 10,000 ports, can do a huge job for you. In short, if you're interested in learning more about video routers in general, about video switching, and how all of this works, or if you want a deeper technical discussion or, on the contrary, a more surface level overview, be sure to leave a comment. I read your comments and will try to prepare the next videos based on your feedback. For now, I'll say goodbye, see you next time.